I'm Andreas Dittrich, founder and owner of Enerdrive Limited, Switzerland, Zurich. I'm working in the field of power electronics, control design and applications in this field, regenerative energy, drive control, for about now 25 years. So I studied electrical engineering in Germany, in Dresden, Technical University. I graduated at the same university, made my PhD thesis in the field of adaptive control of AC and DC drives. Enerdrive offers services in the field of control design, software development for frequency converters, and for applications like regenerative energy conversion, wind power systems, photovoltaic systems, battery storage systems, also for static power supplies, or electronic power supplies for AC applications, for systems regarding which are targeting grid quality, like active filters. Yeah, customers are some companies which are working in the field of or have products in the field of wind power, battery storage, linear drives, also power supplies for transformer testing, active filter applications. This is the main area. We use, of course, simulation tools, standard simulation tools like MATLAB, Simulink, Plex. The most important, or a very important part of the design process is, of course, to use hardware-in-the-loop simulation, where we combine our control hardware with hardware-in-the-loop system from Typhoon. I was one of the first serious customers. This was I would call it a very happy coincidence at the time, because I was looking at the very beginning of Enerdrive. I was looking for a system where I can test and develop my software and also the control electronic. And just at this time, Typhoon was starting to market their simulation system, and somehow we found each other. And of course, the Typhoon device at the time was not flawless, and so it developed some kind of beta testing cooperation, which is ongoing, I would say, to a certain degree until today. A lot of improvement, starting from the hardware. I mean, the very first device, which is now still residing in some kind of museum, and looking at the capability of current Typhoon simulators is a huge difference, a huge progress. Also the tool chain itself, the library, the component library, the capabilities of visualization, of scripting, of included tools to support data processing, to support editing and so on. It's quite a big development. Yeah, in the first place, control and software development for a company like Enerdrive would not be possible without such a device, or not effective, because I don't have the time and also not the funds and cannot spend the effort to develop my own hardware-in-the-loop kind of testing system, or to build hardware test stands or something like that, especially for power electronic applications in the range of several hundred kilowatts and more. This is simply not possible, and so it to a very great degree shortens the development time. It makes control design very effective, and it provides possibilities which you just don't have when you don't have a real-time simulation. I don't have what I would say a daily routine, or I have always different projects. I have different customers. I have new challenges and new problems to fix, and so it's never something to get bored or to find it's not longer interesting, and always new things what you have to face and so on. Hardware-in-the-loop system provides also some very good support and help to look into special problems which are coming from the field, from the customers. I mean, for example, most recently I had some issues to look into which came from nonlinear behavior of transformers. And regarding voltage control on such transformers, something you're not able to foresee in every detail when you develop such a system. But the Typhoon system allowed me to reproduce this kind of problems quite similar, or quite much in the same way as it happened on the customer side. So, and I could reproduce, I could find a solution, I could fix that, and in quite a short time. I mean, without the systems, I would have maybe go on site to make measurements. You cannot always do the measurements which you want to do. This is it's not always possible. So here you can reproduce a lot of things what are experienced on site and improve the systems and solve problems. You have to know what to expect. It's not only with the Typhoon system, it's also when I'm using Simulink. You have to have a certain, of course you have to have a certain insight into the system. You have to know what has to come out of what you're doing, and who is to blame for things which are not working as they should. Do you have to blame it on Typhoon? Do you have to blame it on yourself? So this is this happens all the time, of course, but when you know how things work and how they should work, it's of course possible to divide between the causes of some misbehavior and find out what's going on. When I close a working day and I can say I accomplished something, I fixed the problem, I made the customer happy, and I found a new solution to some issue, some problem. This is what I say as success in my business. Yeah, I think I'm a little bit an advantageous position regarding working with Typhoon support, of course, because of the year-long cooperation we have, and so I cannot complain at all, actually. And when I have a problem, I get always a very, usually a quick and very competitive answer. Sometimes I'm getting the response that I did something wrong. Sometimes I get the response that there's something to fix on the Typhoon side. So that's the cooperation is quite satisfactory. Yes, I had the chance to visit Typhoon office several times. I'm very impressed all the time of the engagement of the engineers, also of the knowledge and competence, and I think this is really a very good working company with a good product. I think microgrid applications are a very suitable target for developing with this hardware-in-the-loop system. Of course, you need for a real microgrid application with a number of components working together and everything, you need a quite extensive tool set already. So, but such a microgrid can be such a complex system with many interactions between loads and sources and transmission and everything, that it's hardware-in-the-loop simulation is just something what you cannot go without it. No, definitely not. To all others, I would recommend it warmly, most warmly.